Hello, ladies and gentlemen. Welcome to our presentation. My name is Hamidreza Ostadabbas. I'm head of the Geoinformatics department at the STEG Stadtentwicklung company in Stuttgart, and also the co-founder of the GIS-World Tech. My colleague Mohammad Hosseingholizadeh, also the senior GIS geospatial software developer, and also the co-founder of the GIS-World Tech. Today, we are talking about the real-time CO2 and district heating visualization in 3D urban digital twins using GeoAI and open geospatial data. So let's jump to our challenges, which bring us here. Recently, improving energy efficiency and reducing CO2 emission within the urban redevelopment area playing very important role for us. And energy assessments often involve complex data handling and multiple disconnected tools or devices to analyze the condition before and after the renovation. So, to have the reliable estimation of the CO2 reduction requires extensive expertise and tool and tech and technology in this way. And this is the very first, challenge or question to us: how to get the first estimation of the CO2 reduction and energy demand with the only minimum number of the inputs, and without requiring the high knowledge somehow in the energy scope. How we can have it with just even less than the 10 parameters to have this result. And another important challenge or important question to us is that how to clearly show the result and communicate with the non-expert users, because as the moderator said, we are coming from the city development, and the communication with the people without too much GIS experience or knowing about the what is the AI, what is the digital twins. It's very important how the result will be delivered to them, and it must be in the easiest format, because they are just searching for the result in this way. And another thing is somehow the challenge, or is somehow the input of our GeoAI app, using the open geospatial data effectively. And because as we are based in Germany, we are using the German cadastral data, ALKIS data, and you are maybe informed about this every 2 years, or after a year it will be updated. Maybe the new geometry will be added, or some data set will be removed or deleted, and that this app must be intelligent enough to be to get the new data and to calculate this CO2 emission or heat grid in this way. So we need the intelligent system to connect open cadastral data, building information, and real-time visualization for integrated energy planning and public awareness. What is the solution? Actually, after somehow 10 years experience in the city development and working with the GIS system, machine learning, AI, it came to our mind, the set of the GeoAI-powered APIs integrate open geospatial data, ALKIS data, CityGML data, that I will explain to you later on about this data, to create the digital twins for the urban energy analysis. And APIs also can be connected to the web apps, QGIS, ArcGIS, or any other GIS software for seamless connectivity. As you see in the images, for example, we have in the second image, we have the QGIS software. It can be also the ArcGIS. And for example, we have the above image is from the WebGIS. Automatically calculate energy demand and CO2 emission with the minimum number of inputs, allowing the fast and reliable, assessments in this way. Since the usual way is if you are calculating this energy demand or CO2 emission, you need many parameters from each building. So with this GeoAI app, we just minimize that process, and the AI will, estimate or guess or prediction in this way. Yeah, and providing the real-time 2D and 3D visualization and dynamic CO2 reduction chart for clear interpretation for entire community. As you see, we have in the first image, we have also the chart, dynamic chart will be updated according to the CO2 calculation. And also we have the 2D, as you see in the WebGIS, and we have the 3D that we are using the Cesium for the 3D visualization. So, auto-generation of the district heating layout through the simple polygon selection. What does it mean? So, Mohammad, my colleague, will explain to you later on the app to show you how it will be working. Just by drawing a simple polygon, we can have this result at the end. So, the base of the system. As I said, we are using the open source data. What is this open data? Free, available, and everybody can use it maybe in the business mode or in the educational mode in this way, and no extra cost, because we are coming from the industry, and this is a very important point for us, to save the money, not paying too much for the software, and because of that, this idea come to us. The main data sources that we are using, the ALKIS data. This is the German cadastral data, and which contains the parcel boundaries, building footprint, and land use details, which is connected to each location. CityGML data, 3D city model, which contains the volume area for each building, Cesium 3D tile, and OpenStreetMap. Why we are using the OpenStreetMap? Because we can have the for the better context and visualization. Maybe we would like to add the parks, roads, and some other information. And it's clear why we are using them. First of all, free, reliable, because these data are authorized from the government, and you can trust those data. And the connection between those systems is completely possible when we are using those data. This is the workflow of our GeoAI app. Open source data, ALKIS data, CityGML data, OpenStreetMap, OSM, plus the user input. What is the user input? Because, for example, we need some kind of information from each building, which you cannot capture it. You are not inside the building. And in this model, we are using the QField app, which is the open source app, plugin inside the QGIS. We can capture this information, and by running GeoAI app, we have the energy demand, we have the CO2 emission. And by having this energy demand and building geometry, by choosing the specific zone of our city area that you are living or you are working, in this way we have the district heating network and heat density. Here is our model input. As I said, user input, construction class year. In some cases in the CityGML data, we have those years, but they are not, in some cases, trustable, because this value is very important for this energy demand calculation. Heating system type, it must be definitely from the owner of the building, because we cannot watch it from outside. And status of building component like a windows and outer wall, roof, and some other information. And app input has the building footprint, ALKIS data, building volume and area, and U values. What is our output from the GeoAI? Energy demand, as I said, specific energy demand, and CO2 emission. And the usage of this result. CO2 emission prediction for actual status of the building. As you know, in Germany, we have a lot of buildings. We are not creating the new buildings. We are doing the renovation for each building. And later, we have the CO2 emission estimation after building renovation. And the point is that this comparative analysis of pre- and post-renovation emission to quantify reduction potential, and this is exactly what we need, that to do some kind of analysis in after renovation and before renovation. And for our district heating network, we have in our model input we have the defined zone of interest. Mohammad will show you how we can do this. And the default app input is the energy demand of the building and selected building footprint for pipe network generation. And what is our GeoAI output? Optimize pipes routing network, heat density of the main and house connecting pipes. And the usage, this is a very financial part, which is important for the municipality or even some small companies in this way. Economic feasibility of the district heating implementation before and after building renovation, because we can, GIS, and we can do to have, some kind of, budget management in this way. So I will hand over the stage to my colleague. Right now, maybe more interesting part come to you with some videos and explanation about our GeoAI app. Mohammad.
Thank you so much, Hamid. So now I wanted to explain our app, which is powered by 3D and 2D data. So it doesn't need, if you are interested in the 3D and CityGML data, you can work with that. If you are interested in the 2D data, easily you can use that. And it doesn't matter, so if you have a very good system, 3D data and not so 2D data. So let's start. So here it's our application. In our application, you don't need to download any type of data. You can access to full Baden-Württemberg data. It is over that 400 gigabytes of data. The only thing you need just to write the municipality or the city name, then you will have access to the whole data set. It doesn't matter, again, if you have already worked with the ALKIS data or CityGML data, you have already seen that how difficult to process all these data. Here you can see that when you are giving it any type of information, all the data will be handled by the CZM 3D tiles. So easily, so you will just switch the data set and the municipality, and then so there you go, and all the data, it's there, and you can start working. Another thing is the process of the updating of the data. You don't need to even think about the process of the update of data, because all in all, everything will be handled by us. So every time, according to each 2 months, 3 months, the whole data set, the ALKIS and CityGML data in our application will be updated. Another thing, all of our data is API based. It means that it is not dependent to any type of the software. It is not dependent that you are using the ArcGIS, QGIS, web application. It doesn't matter what. The only thing is important, you should have one GIS software that supports the API. Then you can import all the data. So another important thing is the CityGML data. So all you see that right now everything is ready. So everything is hosted by the CZM and the 3D tiles. And then the only thing you need, just selecting one municipality, and all in all, everything is done. And then you will have access to hold the latest version of ALKIS and also the CityGML data. Okay. So as you see that also, it doesn't matter in the QGIS or ArcGIS, you will have one add-on or plugin, and all the data, it will be available just with one search and one click. So the next part is our concept according to the calculation of the energy demand and CO2 emission. For such a calculation, you need a very deep expert, but right now there is no need to any type of the information. The only thing you should know about some very simple components about, for example, what are the building components before and after renovation. So with such application, so in the cities and municipalities, all the things that owner can do, just log in, input the data, and then you can have the CO2 calculation. Then you can easily, for example, you can easily confirm to your customers that, yeah, if you are doing the refurbishment or any type of these things, so your CO2 and energy demand will be reduced easily and fast after the refurbishment. So, and also our GeoAI model. So when you are using our applications, one of our challenges in the calculation of the volume of the buildings and all the surfaces, the area of the outer walls, the roofs, all in all, when you are using our application, all this data will automatically pass to the users. So you don't need to do any extra calculation. You know that how difficult is working with the CityGML data, but all in all, when you are using our application, all data will be passed to our GeoAI model, and our GeoModel model start fine-tuning the U values. So it doesn't matter, so how is the difficult in the municipality, how many buildings is that, how difficult is the geometry. So all in all, in our application with some clicks, so you can have the CO2 values. And also for this application, we have two types of the CO2 calculations, the basic and advanced. In the advanced one, you have more parameters. For example, if you have more than one heating system, you can import them, and you can also confirm your customers or the owner of the building. So after the refurbishment, if you do or changes or connected your building to the, for example, district heating, how much energy demand will reduce and how much CO2 will be reduced and how much they can help the environment to reach the climate neutral, so zero CO2 emission by 2040. So another part is, so we are not only 2D, so it doesn't matter, so if you have a good graphic cards, and also you can run our applications in the 3D. So if you have some people, it's difficult for them to work with the 3D, they can choose 2D, but also you have options to use the same functionality via the 3D dataset. And also the one thing which is very important here is the data security. So all of these data, so you are just putting all your CityGML data on the CityGML, and everything will be handled, the geometry things, by the CityGML and Cesium 3D tiles. The only thing, but the most important thing, is the buildings information, which is according to the laws of the Germany and many countries, so they should be secured. And all of them, it will be on your host and on your own server. Then another thing, you can easily just look at the environment and then just see, okay, if we do the refurbishment, how much CO2 will be saved and how much energy demand. You have your charts, you can just switch between the municipalities and just see how much the changes will appear after the refurbishment. And also, the most important thing, you will have all your chart according to the timeline. So in that case, you shouldn't think about the losses of the data. So if a building is demolished, so definitely you can save some CO2 from this demolished building. And after that, you can convince the municipality that, yeah, but after the demolishing of such a building, you can start building some new one. So then the next part, which is the most interesting part, and this is a district heating. Currently in Germany, we have lots of municipalities like Sindelfingen, Almendingen, and they have already existing heating system. But district heating is one of the efficient way for reducing the CO2 and also reducing the energy demand. And so it is one of the big challenges. So with this application, you can just, by some clicks, you can use the auto routing tools. You can see all the pipes dynamically just with some clicks. So it is not very well accurate system that you can do it in the Autodesk, but it can give you very fast the first estimation, all of the costs and how it will be look like, and which type of buildings are able to connect it to the heating system or not. Because again, according to the law of the Germany, all the owners can say that, yeah, I don't want it to connect it to the heating system. So easily you can just remove this building and then you can estimate and do all the calculation very fast. So again, you can see that you can do it in the 2D or 3D. 3D is absolutely perfect because you can also show it for non-expert people. So all in all, in this application, with the GeoAI tools, we can do all the routing systems and also the heat density part. So, and then the last thing, with these applications, you don't need to be an expert in urban planning to calculate the CO2 and energy demand. The only thing you should have a GIS software, or you should have access to our application. With some clicks, you can end to the end result, and you can understand how much CO2 will be reduced during a time before and after refurbishment. So, thanks a lot for your attention.